y'all, let's go ahead and talk about parallel and perpendicular lines. We're also going to talk some about intersecting and coinciding lines, but mostly we're going to focus on parallel and perpendicular ones. So first, let's get some just information down about all of these kinds of lines. So parallel lines look like that, like railroad tracks. Hopefully from your investigation, you know that parallel lines, if you look at just their equation, they have to have the same slope, the m value, but they have to have a different y-intercept, b values. Perpendicular lines are lines that intersect each other at exactly at 90-degree angles. So they can be tilted, but the angle created by their intersection has to be a right angle. It has to be like a perfect corner of a piece of paper. What are the rules? The rule is really specific here. We don't care about the y-intercepts, but the slopes have to be opposite reciprocals. Let's talk about what that means. So an opposite reciprocal, when you think opposite, think sine. So we're talking about positive versus negative. And a reciprocal is a flip. So for example, if one line has a slope of 2/3, a line perpendicular to it, since this is positive, the line perpendicular to it will have a negative slope. And what you're going to do is reverse the numerator and the denominator. So instead of 2/3, it's going to be 3/2. Those are opposite reciprocals of each other. Let's do another example. Maybe if one slope is a -1/2, then the slope of a line perpendicular to that line, instead of negative, it's going to be positive, and instead of 1/2, it's going to be 2/1. And as you guys know, we don't have to put the over 1 if it's an integer value. All right, then let's say a line starts off with a slope of -3. Remember, that's a -3/1. So what do we do to find the slope of the line perpendicular to it? We're going to change the sign, so it's going to be a positive, and we're going to switch the numerator and denominator, or flip it. So it's going to be a positive 1/3. Those are always the specific relationships between the slopes of perpendicular lines. One more is, what if the slope of a line is 1? So think about that. That's a 1/1, and it's positive. So the slope of a line perpendicular to that is going to be a negative, and then you flip it, but it doesn't change it. So a -1 or a -1/1. So those are some good examples. All right, intersecting lines that are not perpendicular to each other, all we care about is that they have different slopes. As soon as they have different slopes that are specifically opposite reciprocals, then we can be more specific and say they're perpendicular. And finally, coinciding lines. Coinciding lines, if you notice, there's kind of a blue and a red part of that line. They're lines that lie right on top of each other. That means they're the exact same line. So exact same lines better have the exact same everything. Same slope, m value, and same y-intercept, which is the b value. Now, initially, coinciding lines may not be in the same format, so maybe one will be in standard form and one will be in slope-intercept form, but once you rearrange them, you'll see that they have the same everything, so therefore they're coinciding. All right, the other thing we're going to talk about in terms of parallel and perpendicular lines are horizontal and vertical lines. So just a reminder here, if we want to write the equation of a horizontal line, remember horizontal lines have a 0 slope. The format is always y is equal to, and then the number that represents the y-intercept of that line. And vertical lines always have an equation. It's kind of opposite of horizontal. Vertical lines have undefined slopes, and their equations are x is equal to, and then whatever the x-intercept of the line is. And then in terms of parallel and perpendicular, a couple of notes to make is all horizontal lines are parallel to each other. That should make sense because they all have a slope of 0, so their lines are going to be horizontal to each other, unless, of course, they're the same line, and then they'd be coinciding. All vertical lines are parallel to each other, and any vertical line is perpendicular to any horizontal line. So keep those things in mind as we do some examples. So first we're going to look at 2 different equations for linear functions, and we're going to determine whether these would be parallel, perpendicular, intersecting, or coinciding. Well, what do we need to identify? Look up here. All of these examples had a rule that had to do with the slope. So that's the key, is first to identify the slopes of the lines, and the only one we care about for the y-intercept is when we're distinguishing between parallel lines and coinciding lines. So the first thing to always look for is the slope of the line. Now, that first equation is easy because it's already written in slope-intercept form, so we can say that the m, or the slope, is 2 for that first equation. For the second equation, we're in standard form, so we need to rearrange it in order to identify the slope. So let's go ahead, and we're going to isolate our y value. So I'm going to subtract 4x from both sides, and then I'm going to divide both sides by 8. Now remember, we've got to divide not only the 12 and 8, but we've also got to divide the -4x and 8. So 12 divided by 8, that would be 12/8, which reduces down into 3/2. and then minus 4 over 8, which would be a negative 1 over 2. Now, this is not written exactly in slope-intercept form. It's b plus mx, really. So you need to remember that the slope is always what's connected to the x value. So now we have, for the first line, we had a slope of 2. For the second line, we have a slope of negative 1/2. Remember, a slope of 2 could be 2 over 1. So notice the two lines. One is positive, one is negative, and they're flipped. The first one is 2 over 1, and the second one is 1 over 2. So what does that tell us? That these two lines are perpendicular. And as I've mentioned before, we don't care about the y-intercept. Perpendicular lines can have the same y-intercept as each other or different ones. All right, for example 2, hopefully you remember point slope form. Again, this has nicely given us the slope of that first line. And it won't always be 2, but for this one it is 2 again. So for the second one, again, we're in standard form, so we need to solve for y in order to identify our slope for that second equation. So we're going to subtract 8x from both sides and then divide by 4. Remember, we divide both the 12 and the negative 8x by 4. So 12 over 4, that's going to be a 3, and then minus 8 over 4. So a minus 8 over 4 reduces or simplifies down into a negative 2. So our slope here is negative 2. So some of you might initially go, oh, they're perpendicular because one's positive and one's negative, but they aren't reciprocals of each other. So all we know about these two lines is that their slopes are different, so therefore they are only intersecting, but they're not perpendicular. Okay, so example 3 is going to go along with our table above about horizontal and vertical lines. So if I were to graph y is equal to 4, remember, for horizontal lines, it's y is equal to, and then the number you see is the y-intercept for the line. So if our y-intercept is at 4, then the equation y equals 4 would look like this. All right, so that second equation, it's kind of in a weird format as well. So let's go ahead and get the y by itself. So I'm going to subtract 3 from both sides. So then we end up with the equation y is equal to negative 3. Again, we're dealing with a horizontal line. And what's the negative 3 represent? That is our y-intercept. So if I were to graph y is equal to negative 3, it would look like this. And how do those two equations relate to each other? They are parallel. All right, let's move on. So for example 4, we've got a slope of 2 for our first equation. It's in slope-intercept form. And then be really careful. A lot of students would say that the 2 right here is the slope of that second line. But remember, from our table, it's y is equal to not the slope, but y is equal to the y-intercept. So that 2 right there is our b value. In fact, if it's a horizontal line, our slope is 0. So how do our slopes compare to each other? They're just different. So again, we're dealing with an intersecting line, or a pair of intersecting lines. All right, next example. Both of these are in standard form. So what we need to do is convert both of them so that we can see their slopes. So first thing is I'm going to subtract 3x from both sides here. And I'll end up with 2y is equal to 8 minus 3x. Now we're dividing both sides by 2. Remember, you've got to divide both the 8 and the negative 3 by 2. So 8 divided by 2 is 4, and then negative 3 over 2 can just be left as negative 3 halves x. What is our slope? It's our coefficient of our x value. So our slope for that first equation is negative 3 halves. All right, so for the second equation, I'm going to get y by itself again. So I'm subtracting 6x from both sides, and then I end up with 4y is equal to 12 minus 6x. Now we're going to divide both sides by 4. Remember, we've got to do 12 divided by 4, which is 3, and then negative 6 over 4. Those are both divisible by 2, so that gives us a negative 3 over 2x. Now notice here, we've got a slope, the coefficient of the x term. Our slope is negative 3 halves. So we can automatically go, oh, the two lines are parallel. But for parallel lines, you've got to check one more thing, and that's that the y-intercepts are different. And here, for the first line, we've got a y-intercept of 4, and for the second line, we've got a y-intercept of 3. So we do, in fact, have a situation where the two lines have the same slope, but a different y-intercept. So we are dealing now with parallel lines. And finally, this is just understanding the format of these lines. Hopefully you know that these are going to be horizontal and vertical. The top one is our horizontal line. Remember, horizontal lines have a slope of 0. The bottom one is a vertical line. and all horizontal lines are perpendicular to vertical lines. All right, so let's move on. So what we're going to do now is we're just going to focus on parallel and perpendicular lines, and we're going to use the properties of those lines to write equations of new lines. So let's do those. So for example 7, it says write the equation of a line that's parallel to this line right here and that passes through this point right here. So here's the deal. The only reason we need that first equation is because we know that parallel lines have the same slope. Well, if we know the slope of this line, then we know the slope of the line that we're trying to find. So we have that for the equation of the line that we're trying to write, we know its slope is going to be 6 because it's going to be the same as that line. And then we know that it's going to go through the point 5, 1. So we've done these before now. The only thing that's different between this example and the examples you've done in the past is now you just need to know the rules with parallel and perpendicular lines in terms of their slopes. So this first equation, I'm going to use point slope form. So here's our the 6 is our m value, and then the 5 is going to be our x1, and the 1 is going to be our y1. So let's go ahead and plug into point slope form. So it's y minus y1, which is 1, is equal to m, which is 6, times x minus x1, which is 5. Now, notice in the equation, I didn't tell you that you had to write it in any specific form, so you could leave it there. Now, for the sake of just a little bit more practice, if I did ask for you to convert this into slope-intercept form, then you would distribute the 6, so you'd have y minus 1 is equal to 6x minus 30, and then isolate your y value by adding 1 to both sides and getting 6x minus 29. And notice, we've got these two lines, and they are, in fact, parallel to each other. They both have a slope of 6, and they've got a different y-intercept. All right, so for example 8, we're going to write the equation of a line that is now perpendicular to this line given. Well, why do we need that equation? Is only because it helps us find the slope. If the slope of the line that we're comparing to is 3, and we want a line that's perpendicular to that one, remember, we're going to flip the slope. So instead of 3 over 1, we're going to put 1 over 3, and because the original line was positive, our slope is going to be negative. So now we've got an x and a y value. I'm going to go ahead and immediately use slope-intercept form here and plug in for y is equal to mx plus b. We're going to plug in y, m, and x and solve for b. So our y is 5 from the ordered pair we're given. Our m is negative 1/3. Our x is 12 from the ordered pair given. And now we can just simplify and isolate our b value. So 5 is equal to, remember, operations with fractions, top times top over bottom times bottom. So this will be a negative 12 over 3, which is the same thing as a negative 4. And now to isolate our b value, we're going to add 4 to both sides and find that b is equal to 9. Now we have the slope of our line and the y-intercept of our line, so we can write the entire equation of y is equal to a negative 1/3 x plus 9. And notice we've got a line that is in fact perpendicular to that original line because they have opposite reciprocal slopes. All right, for example 9. These are conceptually maybe a little harder, but computationally you don't really have to do any math. So here's the deal. We want to write the equation of a line that is perpendicular to y equals 3. I want you to think about what y equals 3 would look like. Hopefully from the front page you understand that that is a horizontal line that has a y-intercept of 3. So the equation or the graph looks something like that. This is y is equal to 3. Now we want it to pass through the point negative 4, 7. So I'm just going to sketch this. Let's say negative 4, 7 is right here. So we want a line that is perpendicular to this one that goes through that point. So think about what that would look like. It's going to be a vertical line that passes through that point given. Well, if it's a vertical line, then we know that the equation is x is equal to whatever the x-intercept is. Well, here is our x-intercept. What would that number be? If you look at this point right here, you know that the x-intercept is at negative 4. So that's the equation of a line that is perpendicular to y equals 3 and passes through the point negative 4, 7. And finally, we're going to write the equation of a line that is parallel to y equals 3. That passes through the point negative 4, 7. So let me sketch that again. So here is our y is equal to 3, and let's say negative 4, 7 is here. Now, we want the line to be parallel to y equals 3. Well, that means it's going to be another horizontal line. So it's going to look like this. What's the equation? The equation of a horizontal line is y is equal to whatever the y-intercept is. Well, think about that. If I extended my y-axis here, what would this number right here be? The y-intercept is going to correspond with the y-coordinate of the point. So my final equation would then be y is equal to 7 because the y-intercept is 7. All right, I will see you guys next time.